Today, we will go over review problems for the inequality portion of the midterm test. Remember, the test will be on Thursday on Kid'em, so you need to bring your computer and charger on Thursday. The first problem says solve 2x is less than 10 and explain how to find the solution set. So in this problem, we would solve this inequality the same way we would solve it if it was an equation. So I need to get x by itself. 2x is multiplication. So we're going to divide by 2 to get x by itself. If we divide the left by 2, we must divide the right by 2. And now we end up with x is less than 5. Now, because this is an inequality, we're not going to get one number for an answer. We're going to get a whole group of numbers. So the answer to this is all numbers less than 5. So this could be 4, this could be 0, this could be negative 20. As long as the number is less than 5, it will be a solution in this solution set. Lynn is solving the inequality 15 minus x is less than 14. She knows the solution to the equation 15 minus x equals 14 is x equals 1. How can Lynn determine whether x is greater than 1 or x is less than 1 is the solution to the inequality? So with an equation, you're finding the one number that makes the statement true. But with an inequality, you're going to get all of the numbers on one side or the other of that dividing point. So in this situation, 1 is our dividing point, and we need to know if every number bigger than 1 is the solution, or if every number smaller than 1 is the solution. To do this, we can pick any number and see if it makes the original inequality true. If it makes it true, then all the numbers on that side of 1 will be the answer. If it makes the statement false, then every number on the other side of 1 will make it true. So my personal favorite number to test, if I can, is 0. So we would take the original inequality and we're going to substitute 0 in for x. If we do that, 15 minus 0 is 15. And 15 is not less than 14. So if 0 doesn't make it true, then none of the numbers less than 1 will make it true. Therefore, the solution is x is greater than 1. Because 0 makes the inequality false. And if 0 makes it false, every number less than 1 will make it false. A cell phone company offers two texting plans. People who use Plan A pay 10 cents for each text sent or received. People who use Plan B pay $12 per month and then pay an additional 2 cents for each text sent or received. Write an inequality to represent the fact that it is cheaper for someone to use Plan A than Plan B. Use X to represent the number of texts they send. So for Plan A, this is going to be 0.1x because 0.1 is 10 cents, and we're going to multiply that 10 cents by x, which is every text sent. Plan B is going to equal 12 for the $12 per month plus 0.02x to represent the 2 cents times every text sent. Now, if we want Plan A to be cheaper than Plan B, we need to write 0.1x is less than 12 plus 0.02x. And this would represent the inequality. For number 2, they want us to solve this. So we could start with 0.1x less than 12 plus 0.02x. We're going to move the x to one side by subtracting 0.02x from both sides. And this would give us 0.08x is less than 12. 0.08x is multiplication. So to get x by itself, we're going to divide by 0.08, and we're going to do that to both sides to keep it equivalent. And we're going to end up with x is less than 12 divided by 0.08 equals 150. And x is the number of texts. So, if somebody were to send less than 150 texts, then Plan A would be cheaper. If someone were to send exactly 150 texts per month, then the plans would be the same cost. And if somebody were to send more than 150 texts per month, then Plan B would end up being the cheaper one. Claire made an error when solving negative 4x plus 3 is less than 23. They show us the steps that she made, and they want us to describe the error that she made. So if we look in her first step, she subtracted 3 from both sides. This kept it equivalent, so that is still good. In the next step, she divided both sides by -4 to get x is less than -5. The mistake she made was with our less than symbol. If you divide by a negative number, you must flip the sign. So the correct answer should be x is greater than -5. If we wanted to check this, the correct answer would be an x value that is greater than -5. So we could try 0. -4 times 0 plus 3 is less than 23. -4 times 0 is 0. 3 is less than 23. And we see that we're correct. If we had forgotten to flip the sign like Claire did and say that x is less than -5, then we could try a number such as -6. -4 times -6 is 24. And 24 plus 3 is 27. And 27 is not less than 23. So you can see that Claire's answer was wrong because she forgot to flip the sign when she divided by a negative. Diego's goal is to walk more than 70,000 steps this week. The mean, this is average, number of steps that Diego walked during the first 4 days of the week is 8,019. So we can say 8,019 times 4. 4 times 9 is 36. 4 times 1 is 4, plus 3 is 7. 4 times 0 is 0. And 4 times 8 is 32. So we know that Diego walked 32,076 steps per day, or total, during the first 4 days. So we can take the 70,000 that is his goal, and we can subtract the 32,076 that he already walked. We're going to borrow 1 from 7,000. Now we have 10 minus 6 is 4. 9 minus 7 is 2. 9 minus 0 is 9. 9 minus 2 is 7. And 6 minus 3 is 3. So Diego needs to walk at least 37,924 steps in the final 3 days. Number 1 says write an inequality that expresses the mean number of steps that Diego needs to walk during the last 3 days of the week to walk more than 70,000 steps. So remember, we want to be more than this 37,924. And we want the mean, which is average, number of steps per day. So we're going to take 3 times x, and that needs to be greater than, because we want more than the 70,000, and it's going to take 37,924 more steps to equal the 70,000 total. So x is daily steps. So 3 times x is multiplication. So we are going to divide. Let's go ahead and bring this down to number 2. To get x by itself, 3x is multiplication. We're going to divide by 3. And we're going to do it to both sides to keep it equivalent. So now we have x must be greater. 3 goes into 3 once. 3 goes into 7 twice with a remainder of 1. 3 goes into 19 6 times with a remainder of 1. 3 goes into 12 4 times, and 3 goes into 4 once with a remainder of 1. So x must be greater than 12,641 and a third. So number 2, if the mean number of steps Diego walks is 12,642, will he reach his goal? The answer is yes, because 12,642 is greater than 12,641.33. So yes, if we wanted to check, we could say 12,642 times 3. 3 times 2 is 6. 3 times 4 is 12. Carry the 1. 3 times 6 is 18. Plus 1 is 19. Carry the 1. 3 times 2 is 6. Plus 1 is 7. And 3 times 1 is 3. So if we took the 32,076 from the first 4 days, and we added the 37,926 from the last 3 days, 6 plus 6 is 2, carry the 1. 1 plus 7 is 8, 8 plus 2 is 10, carry the 1. 1 plus 9 is 10, carry the 1. 1 plus 2 is 3. 3 plus 7 is 10, carry the 1. 1 plus 3 is 4, 4 plus 3 is 7. He would walk 70,002 steps in a week, and his goal was to walk more than 70,000 steps. So now we've proven that yes, he would reach his goal of walking more than 70,000 steps this week. To qualify for a loan from a bank, the total in someone's checking and savings account together must be $500 or more. Which of these inequalities best represents this situation? Well, the first one, x plus y is less than 500, represents having less than $500. That's not what we want. The second option says we have less than or equal to $500. That's not what we want. The third option says we have more than 500, but this one says it must be $500 or more. So the correct option would be the fourth one. This says the savings and checking added together is more than $500 or equal to $500. Number 2 wants us to complete the graph so that it represents solutions to an inequality representing this situation. Be clear about whether you want to use a solid or dashed line. We want a solid line because we have greater than or equal to. This means we want everything above the line and we want everything on the line. So we're going to leave the solid line and we're going to color everything above the line because this would be the region where we have more than $500, and the line itself would be the region where we have exactly $500. So everything in the red shaded region and everything on the line will make this true. The soccer team is selling bags of popcorn for $3 each and cups of lemonade for $2 each. To make a profit, they must collect a total of more than $120. So more than is our key words. Write an inequality to represent the number of bags of popcorn sold, P. So popcorn is $3 each, and we're using P. And the number of cups of lemonade sold, C. Well, lemonade is $2 each, and we want to make a profit, so it must be greater than $120. Part 2. Graph the solution set to the inequality on the coordinate plane. So what we're going to do is look for our x and y intercepts. So first, I'm going to say, what if we sold no popcorn? Three times 0 is 0. Two C is multiplication. So the opposite is division. And I must divide both sides by 2. And I find out that cups of lemonade must be greater than 60. So I can put my y-intercept at 60 on the y-axis. Now I'm going to say, what if I sold no lemonade? 3p plus 2 times 0 cups of lemonade must be greater than 120. 2 times 0 is 0. So 3p must be greater than 120. 3p is multiplication, so the opposite is division. I need to divide both sides by 3. And this tells me p must be greater than 40. So I can put my x-intercept at 40. But this goes into number 3. Explain how we could check if the boundary is included or excluded. We only care about having more than 120. So when we get our intercepts, what we're saying is our cups of lemonade must be more or greater than 60, not that they must be 60. And when we look at our bags of popcorn, we say that it must be greater than 40 bags of popcorn, not or equal to. So this is going to be a dashed line connecting them, and we only care about the combinations that are more than. So everything in the red shaded region gives us more than $120 profit. So the boundary is not included because it would collect exactly $120, and they need more than $120. So anything in the red shaded region gives them a profit by making more than $120. Anything on the boundary line would give them no profit because they would break even by earning exactly $120, and anything in the unshaded region would make them lose money because they would not make $120. They would make less than $120. Tickets to the aquarium are $11 for adults and $6 for children. An after-school program has a budget, that is our key word, of $200 for a trip to the aquarium. If the boundary line in each graph represents the equation 11x plus 6y equals 200, which graph represents the cost constraint in this situation? Anytime you see the word budget, budget means less than or equal to. If you have a budget of $200, you can spend less than $200, or you can spend exactly $200. So less than means we want the region below the line, less than, and equal to is the line. So if we want less than or equal to, we want the region below the line and we want the line. So we want this choice in the bottom left, the shaded region below the line says we spend less than $200. The region on the solid line says we spend exactly $200. Both of those options still maintain the $200 budget. Tyler filled a small jar with quarters and dimes and donated it to his school's charity club. The club member receiving the jar asked, "Do you happen to know how much is in the jar?" Tyler said, "I know it's at least $8.50, but I don't know the exact amount." So the key words here, at least. So it could be exactly $8.50, or it could be more than $8.50. So at least tells us we're going to have greater than or equal to. Number 1 says write an inequality to represent the relationship between the number of dimes D. So a dime is worth 10 cents. So 0.1 times the number of dimes plus the number of quarters Q. A quarter is worth 25 cents. So 0.25 times the number of quarters and the dollar amount of money in the jar. We said at least $8.50 means greater than or equal to $8.50. Graph the solution set to the inequality and explain what a solution means in this situation. So we're going to find our intercepts. First, we'll say, what if we had no dimes? So 0.1 times 0 plus 0.25 Q is greater than or equal to 8.50. 0.1 times 0 is 0. So we have 0.25Q must be greater than or equal to 8.50. The opposite of multiplication is division. So we divide both sides by 0.25. And we find out that Q must be greater than or equal 8.5 divided by 0.25 is 34. So Q must be greater than or equal to 34. So we'll put our y-intercept right about here. Next, we're going to say, what if we had no quarters? So this time, 0.25 times 0 must be greater than or equal to 8.50. 0.25 times 0 is 0, so 0.1 times the number of dimes must be greater than or equal to 8.50. We divide both sides by 0.1, and we find out that if there are no quarters, the number of dimes must be greater than or equal to 85. So we could put the x-intercept down here at 85. And now, because we say that these intercepts must be greater than or equal to, that or equal to tells us this is a solid line connecting them. And because we want the total amount to be greater than $8.50, we want the shaded region above these, because more than this number of quarters or dimes will give us more than $8.50. Anything on the line will give us exactly $8.50. And anything in the non-shaded region would give us less than $8.50. And number 3, suppose Tyler knew there was 25 dimes in the jar. Write an inequality that represents how many quarters could be in the jar. So if we say we know the number of dimes, we say 0.1 times 25 plus 0.25 times quarters is greater than or equal to $8.50. 0.1 times 25 is 2.5. We are going to subtract 2.5 from each side. That tells us 0.25 times the number of quarters must be greater than or equal to 6. Now to get Q by itself, we divide both sides by 0.25. And we find out that the number of quarters must be greater than or equal to 24. So if we know there are 25 dimes in the jar, we know there must be 24 quarters or more in the jar. Here is an inequality. 7x plus 6 divided by 2 is less than or equal to 3x plus 2. Select all of the values that are a solution to the inequality. So what we are going to do is take our inequality and the first thing I'm going to do is get rid of the fraction by multiplying both sides by 2. The 2's cancel each other out. And I have 7x plus 6 is less than or equal to. We distribute this 2 and multiply it by everything inside the parentheses. 2 times 3x is 6x. And 2 times 2 is 4. Now you want to subtract the smaller x. So we will subtract 6x from both sides, which means we will subtract 6 from both sides, so that we get the x to one side and a number to the other. 7x minus 6x is x, and 4 minus 6 is negative 2. So, all values that are negative 2 or smaller would be solutions to this inequality. So that could be A or B. Everything else is too big. If we wanted to check, we could take a number like 0 and plug it in and see what would happen. Seven times 0 would be 0, so I would end up with 6 over 2. 3 times 0 would be 0, so I would have 2 on the right. 6 divided by 2 is 3, and 3 is not greater than or equal to 2. So we can see that the numbers here do not work to make this greater than, or to make this less than or equal to. Any of these numbers would actually make it greater than. Find the solution set to this inequality. 2x minus 3 is greater than 2x minus 5 divided by 2. So the first thing I'm going to do is get rid of that fraction by dividing or by multiplying both sides by the denominator, 2. This will cancel out the 2's, and then we distribute the 2 on the left. So 2 times 2x becomes 4x. 2 times negative 3 becomes negative 6. And we have 2x minus 5 on the right. Now, we're going to subtract the smallest x from both sides, which means we're going to add 6 to both sides. Four x minus 2x is 2x, and negative 5 plus 6 is 1. 2x is multiplication, so we're going to divide both sides by 2. And we're going to get our answer of x is greater than 1/2. So our answer is B. Here is an inequality. Negative 10 plus x divided by 4 plus 5 is greater than or equal to 7x minus 5 times 3. What value of x will produce equality or make the two sides equal? So what I want to do is multiply both sides by the least common multiple. The least common multiple for 4 and 3 is 12. So I'm going to say 12 times negative 10 plus x over 4 plus 12 times 5. And we want equality, so we're going to change this to equal. And then I'm going to say 12 times 7x minus 5 over 3. So now 12 and 4 cancel out, and 12 becomes 3, because 4 goes into 12 3 times. And over here, 3 goes into 12 4 times. So now I have 3 times negative 10 equals negative 30. 3 times x equals 3x. 12 times 5 equals 60. 4 times 7x is 28x. And 4 times negative 5 is negative 20. I'm going to combine like terms. Negative 30 plus 60. So this becomes 3x plus 30 equals 28x minus 20. We're going to get rid of the smallest x by subtracting 3x from both sides, which means we will add 20 to each side. +30 plus 20 is 50. 28x minus 3x is 25x. To get x by itself, we will divide both sides by 25. And we will find out that x equals 2. This is the number that will make both sides of this inequality equal. And our last problem says Noah is solving the inequality 7x plus 5 is greater than 2x plus 35. First, he solves the equation and gets x equals 6. How does the solution to the equation help Noah solve the inequality? Explain your reasoning. Solving the equation gives Noah the dividing point. Now he can test numbers on either side of 6 and see which side makes the inequality true. So these are the practice problems to review for the midterm inequalities portion. Tomorrow, I have assigned Khan Academy modules that cover the material and the standards that will be on the midterm test. So tomorrow, you need to bring your computers to school. You will spend class time working on the exercises from Khan Academy so you can get more practice with both equations and inequalities before the midterm test on Thursday.